right, well, good morning, JAWS UG. I am so happy and excited to be here and to get to speak to you. I have been to so many JAWS UG meetings. I think I've actually lost count of the number of times that you have so kindly invited me to attend and to speak. But I'm always very happy to travel and to be here. I recognize some familiar faces, and I see some new faces as well. So let me give you a bit of background, and then I'm going to introduce my special guest. So I'm Jeff Barr. My official title is VP and Chief Evangelist for AWS. I'm a husband, I'm a parent, I'm a grandparent. I have been involved in technology since I was very young. Since before I was 10 years old, I really understood a little bit about electronics and computers, and have followed that interest through my whole life. I love to make things. In addition to being a developer, I love to make things with Lego and 3D printing and with electronics. On the education side, I earned a degree in computer science back in 1985. Went back to school in 2010 to get a master's degree in communication and digital media. I've been a professional developer, meaning that I get paid to write code since about 1979. So even though I really don't get to write code every day anymore, I think I still have a reasonably good understanding of what it takes to be a developer, and especially of the challenges it takes to be a developer in today's world. Now, I actually spoke at the very first JAWS UG meeting way back in 2010, and I'll tell you more about that in a minute. As a little bit of kind of refresher on what I actually do, as Chief Evangelist, my job is to take and understand all of the different interesting services and features that we build at AWS, and to deeply understand those and then explain those to audiences. For 20 years, I did that through the AWS News blog. I started that in 2004, and I finished my time on the news blog in 2024 after writing about 3,300 posts and 1.5 million words. So I've finished up my time blogging, but I still focus on social media. I love to travel for global events like this one, and I also, of course, spend a lot of time meeting with our customers. I have very fond memories of that first JAWS UG meeting, and I was able to find a picture. According to my notes from the time, we had about 130 people attending that first meeting. Was anybody here today? Were you at that very first JAWS UG meeting back in 2010? Yes, yes, amazing. Amazing. We have at least one person here that was at that first meeting. Congratulations, that's awesome. Since then, of course, I've traveled here many times to speak, and I have a really special place in my heart for JAWS UG and for all of you that work so hard to make this event happen, both the annual events and the other events you have around the year. So keep up the great work as you do that. Now, I'd like to introduce my special guest, Mr. Angelo Shirahata. He's the president of AWSJ. He's going to give us a bit of his perspective on where AWS is and his background. As you can see, he was educated at Keio University and at Bond University. Before coming to AWS, he worked at the Nisho EY Corporation, at General Electric, and also at Schneider Electric. So let's welcome Angelo-san.
皆さんおはようございます。近すぎましたね。結構音拾います。本日は朝早くから皆さんこうしてお集まりいただきましてありがとうございます。昨年の11月に、Amazon Web Services Japan 代表執行役員社長に就任いたしました白畑明彦とお呼びします。今日はよろしくお願いいたします。 まずは最初に先ほどのオープニングのところでもお話しされてましたけれども、たくさんのスポンサーの皆さんに支えられてこのイベントが続けられております。皆さんに最初にお礼を申し上げたいと思います。ありがとうございます。私ですね、お世辞じゃなくて本当に今日結構楽しみにしておりました。で、その理由3つお話ししたいと思います。1つ目は4ヶ月の中ですごく早々に感じたことが、今日のやはり AWS を、AWS たらしめているもの、 AWS ジャパンを作っているものってビルダーなんだということを早々にすごく感じたからです。昨年の年末にあったラスベガスのリインベントというイベント、私は初めて行きました。そこで本当に目から鱗というか、こういうことだったのかということが分かりました。多くのビルダーの人たちがものすごい数来ていて、結構なお金かかるんですよね、あれ参加するだけでも。それを、数々のホテルの間で、走りながら、もう全てのセッションを見ながら、床に座ってMac開いていろんなものをそこでいじりながら、ベータバージョンで公開されたてのほやほやのをいじっていく、ディープレーサーっていう有名なマシンラーニングの車を動かす、遊びみたいなのもありますけど、あれも私面白くてずっと見てました。本当にあれを見て AWS ってグローバルで本当にそういうビルダーが作ってるんだなと思いました。的釜 CEO のプレゼンテーションも一番最初に AWS ヒーローズということたちに対する謝辞感謝とレコグニションから始まりました。そして彼が初めて CEO になってからの初めてのアナウンスで話し始めたのがビルディングブロックという話でした。ビルダーがビルディングブロックしてソリューションを作り、インパクトを与えて世界を変えるみたいな、その話から始まったということで、私の本当に2ヶ月目3ヶ月目ぐらいのデビューしている期間の中で、この、いくつもの体験というのがすごくビルダーというカルチャーが大事なんだなということを再認識させてくれました。実際に向こうでも日本からもジャパンナイトで、私多分500、600人の方たちが参加しているようなパーティーで、ご挨拶させていただいたんですけども、もしかすると今日の中にそこにおられた方もいるかもしれませんけど、すごい熱気でした。なので、ビルダーだということです。で、その中の一つの象徴がこのJAWSなんだと思います。東京リジョンができる2011年より前の2010年からこの活動が起こっているということで、まさにこういう皆様の開発者の皆様が AWS の可能性をアンロックしていただいて、その中で東京リジョンができて、今の AWS がジャパンが出来上がってきているという歴史の一部だったグループなんだなというふうにすごく感じてますし、Kindle 化されてるストーリーになってる、東日本大震災の時ですよね。AWS も無償でテクノロジーを提供しますということをすぐ決めましたけども、このグループの皆さんが震災後でストップしてしまっている赤十字の、日本赤十字のウェブサイトだとかいくつかのサイトを復旧させるということをボランタリーにやったことで、あの時にその一つのレガシーが残ったみたいなこともあって、いや知れば知るほどこのグループすごいじゃんというのが、会いたかったことであり、その一つの理由です。2つ目はですね、私ビルダーというカルチャーに共感するところがあるからです。この経歴化するとどこがやねんという感じがするんですけど、最初10年間商社マンやってアフリカにずっといました。次の10年間は GE という発電とか電力の会社にいました。で最後シュナイダーというところにいましたけど、GE の途中で実はやってたことって発電のガスタービン作ってる会社ですけど、そこにおけるコンディションモニタリング、状態監視みたいなことを振動計測だとかあらゆるセンサーの情報に基づいて運用したり、予知保全、プリベンティブメンテナンスするみたいなことをやってたんですね。でもしくは石油化学プラントにおける配管の中の流量を超波流量計を持って計測する、圧力計を持って計測する、そういうデータを集めてプラントを制御する計装っていう世界にいたりするんですね。なんか違うなと思いながら、実は今でいう IoT の世界の走りみたいな分野に実はいたんです。でその後のシュナイダーでは思いっきり IoT の世界にいたので、スマートビルディングだとかスマートファクトリーだとかスマートホームだとかをやっていて、私自身が実は香港でスマートスペースと呼ばれる事業部の、VP をやってた時は、今よりも10年前なんですけど、スマートホームをどうやって作るかということをまさにビルディングブロックしていてですね、まだアレクサとか出る前だったんですけど、その時は、部屋にある最終分電盤のところとかスイッチソケットを持ってた会社なんで、その裏にジグビーのパックをつけて、ジグビーでメッシュのネットワークを作って、そこで通信させるアーキテクチャを作って、そこで電力のとかシーンセッティングだとかコンフォートだとかいうものを制御するっていうことを やってました。日本のベンチャーさんが面白いものを持ち込んできて、自分の家の中でそれを実際に組み立てながら組み合わせて実験して、家族に何やってんのって言われたことがあるんですけど、ちょっとそういうバックグラウンドがあるので、どっちかというとヘビー産業インダストリー産業系に寄ってはいるんですけど、IoT という切り口でいくと、このお客様のために価値のあるソリューションをテクノロジーブリックを組み立ててアーキテクティングしていくみたいな意味では、私の中では結構通じるものがあって、正直最初 AWS の話が来た時、いやいや僕違いますよってずっと言ってたんですけど、ある時に点がつながった瞬間があって、今までやってきたこととなんか通じるんだなっていう瞬間があった。そういう意味でもこのビルディングブロックっていう考え方が私の中には、ピンときますし、ビルダーという人たちの、重要さ、バリューというものがすごく感じる、分かるなと思うところがあるということです。3つ目は、我々の AWS の将来もおそらくビルダーの皆さんにかかっていると思うことです。今日多分生成 AI の話がたくさん出てくると思います。生成 AI この数年まだしばらく続くでしょうが、続々と将来も新しいテクノロジー出てくると思います。そういったテクノロジーを実際にソリューションにするために、そのブロックを組み立てていくというその開発者ビルダーの皆さんたちなくしてはイノベーションは生まれないと思ってますし、 AWS 自身もそういう大切なものを失わない、さらに強化していくような、そんな会社であり続けたいというふうに思っています。はい、ということで、皆さんほとんどの方に初めてお会いすると思うので、ちょっとやや初心表明的なところも含めてちょっとお話をさせていただきましたけども、今日は一日、楽しんでいってください。私も少し参加していろんなところで、皆さんのいろんな事例等をお聞きしたいと思います。今日はよろしくお願いいたします。ありがとうございました。
All right, so it was really wonderful to hear about your background and your perspective on AWS, but also on builders and the importance of building blocks. So we have this audience full of builders here. What might be a piece of advice you could offer builders with respect to AWS and how they could kind of look forward to the future?
いっぱいあるんですけども、私はやっぱりお客様と一緒にその IoT をやってきた人間なので、どっちかというとその背後にあるテクノロジーのプラットフォームとかバックボーンというよりは、お客様のアプリケーションに近いことをするのがずっと好きな人間でした。でだからゆえの、私の信念はやっぱりお客さんと一緒に、問題解決をする、お客様に近いところで話をすればアイディアが湧いてくる。そしてそのアイディアをテクノロジーのブロックを組み立ててどうやって解決するのかというアプローチなんで、やっぱりこの会社がよく言うカスタマーオブセッションそのものなんじゃないかなと思います。
Wonderful. Thank you so much. We all are so excited to meet you and wish you all of the success at AWS. Thank you so much. Okay, so I'm going to talk today about kind of the past, the present, and the future of development. And I want to give you a bit of my personal perspective. What I've observed as a developer is in the course of one career, you can have experience and the ability to use many, many different levels of technology in different generations. When I first started out as a professional programmer, I was working on a mainframe, writing in a very obscure language called PL1. I earlier used microcomputers and mini computers like the PDP-8 and the PDP-11, both very much obsolete but important pieces of history for their time. After that, I was able to write assembly language for several different microcomputers and microprocessors, the 8080, the 6502, 68000. Again, all historic, but very important for their time. Higher level languages have written hundreds of thousands of lines of C code and PHP, lesser amounts of Python and Perl. The thing that I've learned over the years, and I think this is a really important lesson, is at any point in time, you are going to be working with some generation or level of hardware and software. And the current generation is going to be very mature. It's probably had all of the kind of the bugs and the rough edges kind of taken away. It's tried and true. It's somewhat perfect for its time, and you can become very comfortable with that generation of technology. However, at that same time, there's always something new. And because it's new, it's imperfect, it's still got some rough edges, it still could use some further development, but it also represents the future. And what I've found is it's very important to pay attention to, respect that past, respect that history, but to be very, very open to the future, and to make sure that as new generations of hardware and software arrive, that you are open and receptive to them, that perhaps you're excited about being an early adopter of something new, you want to try it out, you want to experiment, you want to get that early experience with these new technologies. That ultimately gives you a really interesting advantage in your career. If you are the person that's always trying out something new, perhaps it's part of your job, but perhaps it's something you do on your own time, with your own initiative. At some point, you're going to go to your job, and you're going to be discussing with your team and with your manager. Someone's going to ask, why don't we use this brand new technology for our next project? If you are the person who's put your personal energy into studying for that next generation, you're the one who can raise your hand and say, you know what, I've already been spending some of my personal time and energy on that. Let me step in and tell you what I already know. So that willingness I've found over the years to be that early adopter has really resulted in amazing advantages in my career, and I've seen other people do this as well. So that is one piece of advice to you, is be that early adopter, try new things as they emerge. During my presentation today, I used the Amazon Bedrock console and the Amazon Nova Canvas model to produce some imagery. And one thing that I really like to do as I'm putting presentations together for different audiences, I want to make sure that I kind of have a little bit of a local flavor to my content. I think it's really important to personalize my content in a way for my audience. And so, for example, here's a prompt where I wanted to talk about tools. And as part of my prompt, you can say, you see, I included the phrase Japanese style in my prompt. So I got a really interesting kind of artistic Japanese. So, but I used the same basic presentation last month when I was in India and in Thailand. And when I was in those two countries, I used the prompt on the left. I want to convey this idea of a developer using somewhat old and primitive tools to write code. So there's my basic image. But then for here, I changed my prompt in a very simple way. All I added was, instead of an English city, I said a Japanese city. And I really like this example a lot because it shows the power of generative AI to make images easily. It allows me to customize for my audience. And of course, I think the images themselves are very well done and very helpful to convey the thoughts that I have. So that's one way I've been able to use generative AI to both improve and customize my presentations. And I hope you'll see that throughout my presentation, and I do hope you find that useful. Okay, so after talking to a lot of developers over the last year, 2 years, I'm getting this sense of fear and uncertainty. We all see these demos of these amazing AI coding tools, and we see, start with a document, do a little bit of typing, here's a program. And developers look at that and they're saying, first, this is amazing. Second, what does this mean for me and my role? This means we're at a very interesting point in time. But what I want to show through my presentation today is this idea of having software tools that help us is nothing new. As developers, we've been building tools since the beginning. But it's absolutely okay to have this feeling of uncertainty, a little bit of just kind of confusion about where we're at, where we're going. So today I want to talk about really a little bit of the history of software tools, and then show you a little bit into the future, talk a little bit about generative AI tools, and also something called formal methods and automated reasoning. We'll talk about some of those futures. But really also important in this is making sure that you understand that even with all these changes and all these new tools, you are still at the center of what happens here. The tools, as always before, they're there to help you. The tools are not going to take over and leave you behind. You are still in control of the tools. Along the way, I would like to give you a bit of advice as to how to best prepare to be a functional developer in this new AI-enabled world. So here we've got a developer. She's trying to write some code, but she's kind of using some kind of last generation tools. So I think what we find sometimes is that we are expected to write the most modern of programs, but maybe we've conditioned ourselves to use the last generation of tools. I think what is also important to realize in our development world right now, there's room for a lot of different ways for people to become software developers. And I do think with the new tools, we're going to actually expand the definition of developers. We're going to see more people with more diverse backgrounds, more skill sets, and I think that's really good and positive for our practice. To me, some of the data points, we'll see informal developers that are totally self-taught. Maybe they just opened up YouTube and they watched programming videos. Maybe they used AI tools to teach themselves. They found some tutorials online, and purely through their own initiative and commitment, they learned how to write code. That's one great route to becoming a successful developer. The traditional route has been actually go to school, earn a degree in computer science, and become effectively a professional coder or professional developer. Yet another route that I see is that we see people kind of with a more kind of a mathematical or scientific background, often taking a very formal approach to development. And there's room for all of these and more in our profession. I want to explain something really central to my discussion here called the virtuous cycle. This is a model we use very often at Amazon when we think about how as we develop one piece of technology, how it feeds upon itself and continues to make the overall kind of generational cycle faster and better over time. Every time we produce a new piece of hardware at Amazon, we actually use that hardware to help us design, simulate, and actually build the next generation. So any generation of processor, we literally run the tools on that processor to help it build its successor over time. As these processors get more and more powerful, it turns out that we can do that better and faster, and so the time between these generations actually continues to shrink. So we call this the virtuous cycle, and this is, we think about many different types of processes within Amazon in this way. So we're about to design some new processor. We simulate the new one on the current generation. We actually do what's called the synthesis to create the logic of the chip. We lay out the physical arrangement of the chip itself. We fabricate that chip, we deploy it into production at AWS, and we then, through that process, we have access to more compute power. So as we do this over and over and over again, The chips that we build, they are designing their successors, and the cycle itself is tending to run faster and faster over time. We can see this with the fact that in 5 years, we've produced 4 generations of the Graviton processors. We started with the original in 2018, and by 2023, we're already at Graviton 4. Each one with additional power, additional cores, additional features, especially additional security features, all on the chip. So when you see processes, think of that virtuous cycle and think how the processes and the steps can actually drive innovation. So that's the hardware side. But the interesting thing is there's a similar virtuous cycle for software. As we build these better and faster computers, they're going to support better and richer coding environments. And one important aspect of software, and I don't have quite the right name for this, but software itself helps us to build additional software. We've got various kinds of tools that can kind of operate on themselves. They can operate on your source code, generate object code. But the fact that the computer can be somewhat self-referential gives us this power that I don't think we see in every kind of technology. So we've been using software to build other kinds of software since the beginning, right? We had the very simplest assembler tools. We use those to build compilers and IDEs and so forth, and our applications. And so when I kind of look at the longer history of software tools, what I see is that these AI-powered coding assistants are simply the next step. It's a nice, clean, logical set of steps that we'll go into in just a moment. And I think it's very important when you think about all these tools are designed to make you as a developer more powerful. They're not there to take away your job. It's not there to replace you. It's a tool to make you as a developer more powerful. So it's an assistant. It's not a replacement. Now, interestingly enough, I know that there's so many different ways that we can be writing code. Is anybody here still actually writing actual machine code with zeros and ones? Nobody? Oh, okay. Anybody actually writing in assembly language, maybe for small devices? Awesome, awesome. Somebody there, real good. Coding in higher level languages. Is that most of us? Okay, some of us. Who is using AI-powered coding assistants right now? Wow, okay, so maybe 25, 30%. Good. Now, it doesn't matter where you are. This is not a test of any sort. This is just to kind of understand that there's this whole spectrum of different places where you might be. Is anybody using things like formal methods to validate your code? Formal methods and automated reasoning and... Okay, that's good. Every audience oh, okay, somebody right there. Good, okay. Every audience I've asked so far, I have not had one person raise their hand and say they're yet using formal methods. We'll talk about that toward the end. Certainly an important part of where our industry will be going. Or is anybody building code for quantum computers? Okay, awesome. Okay, we do have somebody. Awesome, that's great. That's great. There's always at least one person in every crowd, so that is awesome. Again, it doesn't matter where you are on the spectrum, but I think it's important to point out that there's so many different ways that we can interact with our computers and build applications. Let's think for a little bit about kind of what our job is as a developer. To me, this is a definition I wrote myself. Our responsibility is to produce code that meets either self-imposed or customer-driven requirements. And along the way, we probably have some desirable attributes for our code. Of course, we want it to be correct and to behave as expected. We want it to be fast and to make efficient use of resources. We probably want our code to be maintainable so we can come back later and update it as our requirements change. And we kind of want it to be good in some way that we all kind of know what good code is like, but it's a little bit hard to really define in a formal kind of a way. But these are the things that we need to think about as developers. So to me, it's really all about the tools that we use. I want to use a very broad, very open definition of tools, and you'll see why as we get further in. But I want to say that a developer tool is anything that is made from bits that helps us to do our jobs better as developers. It could be a language feature, it could be an executable program, it might be a function or a class library, it might even be some training and reference material. Anything that's ultimately composed of zeros and ones that helps us to do our jobs. Let's think of it that way. So why do all these tools actually matter? There's a great phrase attributed to Isaac Newton that says we need to stand on the shoulders of giants. So the giants, in our case, are those who have come before that have built those earlier generations and layers of tools. It's so important when we think about developer tools to realize that as an industry, these tools ultimately kind of stack up in this really kind of thick set of layers over time. The tools build on the earlier ones, but they can also interact with and be composed with other tools. These are both, we might not even kind of realize it, these are somewhat unique attributes of software. This fact that we can take these two different things and use them together, or that we can build that first generation of tools, and that helps us to build not just next generations, but layers and layers of more sophisticated tools. But also the important is that as we get more memory, as we get more compute power, the tools help us to take advantage of all that compute power. The fact that when you're in your editor or your IDE and it's offering code completion, either something simple like IntelliSense or AI-driven code completion, there's a lot of work happening behind the scenes to make that happen. So I think one of the challenges of a tool developer is to say, I have all this compute power available to me, how can I use it to make my developer more productive? Now here, just kind of, I'll go through this really briefly. What I thought a bit about all the different kinds of tools I've used over the years. From simple things like assemblers and editors and compilers, linkers to take the different assembled parts of the program and put them together. Of course, debuggers. There was a time in our industry where there was something called case tools, where it was, the idea was, case was computer-assisted software engineering. So this was kind of an early attempt to say, we're not going to write code, we're going to do more with diagrams and modeling languages and flowcharts and effectively visual programming. It never quite caught on. It was more of a kind of a manager's dream than a developer's dream, if you will, but certainly part of kind of our evolution. And then we came to the time of the IDE, the Integrated Development Environment. One of the things that, when I think about the IDE, it takes a lot of the things that we built before, puts them all together in one nice package. Our editor, our compiler, our debugger, maybe some of our source code control as well, all put together in that one nice convenient package. And as you can see, there's many different features of each of these tools. My sense is that, kind of looking back in history, whenever any of these new features would appear, we as developers would look at that and say, this is actually a big help to me. This helps me to get my job done better. I mean, I think as we look at the editor features, for example, when editors can automatically indent our code, they can color our code according to the keywords, when the editors have some understanding of syntax, when they're using things like IntelliSense to help us to complete our thoughts. Those are all ways the computer is being helpful. And to my way of thinking, all of these things are simply the steps leading up to our Gen AI coding assistants of today. So if you found any of these kinds of things helpful as a developer, you should kind of think the next logical steps are that I'm going to use my AI coding assistant to help. We can extend that to language features, from structured programming to data types and objects and exceptions and memory safety. All these kind of things were developed over long periods of time to make us into better developers and to help us build better applications. So we've got the compile time features, we've got the runtime features, and none of these were all that controversial at the time. These were all seen as really important steps forward and things that, again, help us make better programs, more correct programs, safer programs, more robust programs. Again, each one helps us to do a better job and to write better code. At a different level, we kind of have to think about, well, from these individual pieces of code, it's also been very helpful over the years, different ways for us to package and then reuse code, either within our own projects, our company's projects, or across the industry as either commercial software or open source code. Macro libraries, standard libraries, classes, open source, all these are ways that we can write something once and then use it multiple times. So I'm trying to get kind of to make an important point here. If we as human beings, when we see a problem, we naturally think of, is there a tool I can build to help me solve that problem in a better way? So we think of the problem, we build a tool, we use that tool, and then ultimately we use that tool to build even more tools. So that's kind of the humans in general. But as developers, we do this exact same thing, aided by increasingly powerful hardware and software. So tools are a good thing. We need to respect the fact that they're going to continue to help us. And my sense is there's a little bit of fear sometimes about this newest generation of the AI tools. I think we should respect them, find great ways to use them to help us to do our jobs better and better. So where are we? As developers all around the world for the last 40, 50, 60 years, we've been building up this kind of collection of software. We have all the different kinds of developer tools that I've talked about in the last 10 minutes or so. The assemblers, the compilers, the editors, the language features, the packages of reusable code, all of the documentation and training, and all the content that we created. So imagine that we can take some or all of that, and we use that to actually build a large language model, an LLM. We train and fine-tune that model. This is where I kind of feel a little bit philosophical. As an industry, we've built all this amazing software over the years, and by putting that into that large language model, we're effectively saying, let's take all the knowledge, all the content, all the code, put that into one model that we as developers can access and use and benefit from. So what do we get? We get this LLM. It's going to have an understanding of development processes, of tools, of documentation, of APIs, coding styles, and code itself. This, to me, is why I see the AI-powered assistants as an evolution of where we have been in the past. We've spent decades building to this point as an industry, and now we say, let's take it all, let's train this model, and let's have these tools to help us get value from all of the work that developers all over the world have done for generations. So let's move from kind of the past into the present and a bit into the future now in my last 10 minutes. As I was getting ready, I found this wonderful meme. So if you don't know, these are punch cards from the 1960s and 70s. And in my early days in college and my first programming job, we didn't have screens, we didn't have laptops. We actually had to put our code onto these punch cards. One column on the card was one character. If you made one mistake, you had to throw away that card and type it over. So you quickly learned to be a very good typist. But this one meme, I think, somewhat represents this anxiety that we have as developers about our coding tools. And I actually asked AI to explain what was going on here. The second paragraph is actually really good. The post plays on the current anxiety about AI taking jobs, drawing a parallel with the 1960s, when compilers began to automate tasks previously done manually, suggesting a cycle of technological displacement in the tech industry. So this to me is actually a perfect representation of the fear that I hear around the industry about AI tools. Needless to say, compilers didn't take away anybody's job. They made computers more accessible to more people, and ultimately more software was written, not less software, and more developers were needed, not less developers. So let's talk about two aspects of what's next. We'll talk about AI-powered coding, and we're going to talk about formal verification. As I've shown, I do believe that AI-powered coding is a very logical next step based on where we've already been. Its goal is to make you into a better developer. I'm going to show you a quick example of how we go from your intent to code without having to do a whole lot of coding in between. It's going to increase efficiency. And ultimately, you want to think about your coding assistant as simply another tool in your toolbox as a developer. It still requires your input, it requires your knowledge, your judgment, your skills. Those all still matter, they're all still very relevant. You're just going to use them in somewhat different ways than before. So I'm going to show you about Amazon Q Developer in just a bit. The other one is slightly different. This is kind of a very somewhat unique or esoteric aspect of development that isn't widely practiced just yet. But the idea is that for some kinds of programs, we can actually prove a program to be correct in the same way you might prove something in math or in geometry. One of the techniques within the whole kind of big world of formal verification is called automated reasoning. And it turns out that as you build very sophisticated, very complex programs, things like Amazon S3 or DynamoDB or IAM, being able to prove important properties of those programs with formal mathematical methods is an incredible way to make systems that are very robust and very scalable. And we'll talk about that in just a little bit as well. So let's talk a little bit about Amazon Q Developer. And I know there are many different coding assistants out there. We're still in the very early days of these assistants. Each one of them gets somewhat better week by week and day by day. My advice would be to, regardless of which coding assistant you're using, get some experience with one or several of these if possible. Because this is the future is coming at us very quickly right now. Okay, so my colleague Sanjeev actually wrote this really nice example, and I'm not going to go through it in great detail, but you can actually watch his YouTube video to see everything happen there. He shows us how we can create an app with Q Developer, and he writes this prompt that within these two sections of his prompt describe the application he wants. So he starts out, and let me just read this. He says, I want to create a full stack web application for sports event management with the following features. So that's his intent, and then goes on to list, this is the front end. He says, I'd like the front end to be written with React.js. I'd like the back end to be written with Node.js and Express. And then list the basic features of the front end and the background. The authentication, the user interface, the actual features to do event management, and the access control for the front end. On the back end, he says, I want an API-based architecture, I need some authentication, I'd like to use an in-memory database, and I need some specific features. And then as the final part of the prompt, Sanjeev says, please provide guidance on how to implement this application with best practices and secure coding standards. So the thinking and the application understanding and the writing that he did result in this document, this prompt. And he takes that prompt, he pastes it into Amazon Q Developer inside of his, probably in VS Code. And then Q Developer goes through and takes a series of steps. It evaluates his request, creates an overall plan. It goes through and looks for all the features that need to be implemented, writes code to implement those features, creates a project structure, adds all the features and files to that project structure, hands you a summary of changes, and then gives you the code. This is the second place where your skill and expertise as a developer come in. Even if you use a coding assistant, it writes all of your code for you, and you simply say the code is great, turn it over to production. You as a developer are still responsible for the content and the quality and the security of this code. So your expertise might change a bit from writing the code to reading, understanding, and reviewing code. But that's the human aspect. That's probably not going to be as automated as easily. Let's jump a little bit forward here. So Q Developer is going to, based on that one prompt, is going to generate the project structure, and it's going to generate code to implement all of those features. Let me jump a little bit ahead here. What Q Developer lets you do, it's going to help you to build faster. It's going to help you to make better use of AWS. It can help you to transform workloads, for example, upgrading code from older versions of Java to a current version, or modernizing your .NET or your mainframe applications. And it's going to also help you to make better use of your data and of various AI features as well. Okay. Let's wrap up with just a quick kind of set of notes on formal verification. The idea here is that this is a mathematically or logically rigorous way to prove a program correct. This has its roots way back around like 1980, when this idea of writing a formal proof to establish the correctness of a program was first proposed. The systems and the methods at that point were fairly simple, and the problem was that you had a program about this big, and then the proof would be about that big. So it was often harder to write the proof than to write the program, and so this remained somewhat of an academic endeavor for a while. In recent years, however, with continued development and with more powerful languages and more powerful computers, this has grown into somewhat it's not quite mainstream, but it's something that will be mainstream, I'd say, within the next 3, 5, 7 years, let's say. It's definitely different than machine learning, where machine learning is prediction, whereas automated reasoning is based on symbolic reasoning. And there's a few different kinds of automated reasoning tools. If any of this seems interesting to you, these are some of the tools that you'd be able to look up and to use. For example, the last one on the screen, called Zelkova, This is a special kind of a program called an SMT solver. And we use this to establish the correctness of things like S3 block public access, the IAM access analyzer, and the VPC reachability analyzer. These are kind of all somewhat leading edge kinds of tools, but these are tools that can help you to build better and provably correct programs. So this entire field of automated reasoning is very fascinating to read about and well worth some of your time. So kind of wrapping up, what should you do next? As always, I encourage every audience, whatever is your interest area, continue to research and to learn more about it. I would also encourage you to try an AI-powered coding assistant, QDeveloper, or there's certainly several others as well, but definitely don't just watch videos, don't just read some blog posts. Go hands-on with a coding assistant and get that real hands-on experience. Nothing substitutes for that hands-on experience. And then if what I've told you about automated reasoning and formal verification sounds interesting, I'd encourage you to start understanding that and seeing ways you can put that into practice as well. If you would like, you can sign up for an AWS Builder ID. We're working to build a community based on Builder IDs and with QDeveloper, so feel free to snapshot that and sign up for your Builder ID as well. And with that, I would like to thank you for your time and your attention. As always, I greatly appreciate these opportunities to travel and to speak. Thank you so much.